Hi, this is Ryan Neal from the USA offices of Neal's Saddlery and Harness, Cowboy Sewing Machines, and High-Tech Sewing Machines. Today we're going to do a feature video on our HM-750SL servo motor. The HM-750SL servo motor we believe to be quite possibly the most advanced and highest horsepower motor on the market today. It also has the ability to run at an incredibly slow rate of speed. Most of the servo motors that are on the market today usually run around 200 to 300 RPM at the absolute slowest speed, but they have a huge fall off in horsepower and torque at that low of an RPM. The HM750SL is capable of generating bone-crushing amounts of horsepower and torque at extremely low RPM. The machine is capable, or the motor is capable of running between 50 RPM all the way up to 2,500 RPM on the high range. Now, a lot of people have asked, well, you know, what's the difference between a higher end motor like the HM750SL and some of the lower end motors that are on the market? For instance, the motors that you see on the discount websites for $100 or $120. Well, we actually have one of the lower cost motors here that I wanted to showcase some of the differences between the 750 and this lower cost $120 motor. So if you look at the 750SL motor here, you can see first off the size of the motor winding, the size of the coils, the size of the magnets that are used inside this motor are much, much larger than what you would see in these smaller discount motors. There's a lot more neodymium magnets in here. There's a lot more copper in our windings, and that allows us to generate a very high horsepower motor that's capable of running at extremely low RPM. The second difference is the bracketry that's used to affix the motor to the mounting bracket itself. If you look at the difference between the size and the thickness and the robustness of these components, you can see that the bracket for the 750SL is much, much thicker, made out of a higher quality alloy, and just all around heavier duty. Now, the next thing I'd like to talk about as far as differences between the 750 and the more common lower cost motors is the speed control box module. This is the lower cost speed control box module. This is the speed controller for the 750. So you can see they look similar, but the 750 is much larger. This is because we have a lot more precision componentry inside here, printed circuit boards, magnetic sensors, and so forth, which make this quite a bit bigger in size and also more complex, which allows for more precise stops and better overall speed control. If we look at the needle positioner modules that we use on our 750SL, you can see that this is a very, very high quality module. It's very, very heavy. It's got a good bit of weight to it. Also larger and also it's larger because it has more internal components inside, which make it a more precise needle positioner. I'll show you, we have the cover removed from one of the very same needle positioner sensor that I was looking at. With ours, you have two separate wheels where you can custom and individually adjust your needle up and your needle down position simply by rotating these wheels. We have two magnetic sensors underneath. These are sometimes called Hall sensors, which detect the absence or presence of a magnetic field. And there's two separate sensors, which allows you to individually set upper position and lower position. This is not an option that's present on lower cost motors. In addition, you can see the printed circuit board that we use in this is much larger, much more complex, more individual circuits, which allow for better customization and better sensitivity with regard to detecting needle position by virtue of these two adjustable wheels. Now, let's compare this needle positioner unit with the one that's on our lower cost motor. You can see this is a much more simplistic design. The printed circuit boards that are inside this are much, much smaller, much more simple in design. As a result, this will not position as well as our higher end needle positioner unit. Also, we want to talk about some of the electronics that are actually inside the motor winding itself. And if we look at the end of the motor winding itself, you can see what we have here is what we call a photoelectric sensor, commonly referred to as an encoder unit. Now, only the higher end motors on the market will be equipped with this electronic piece of equipment right here called the encoder unit. Here's one that is removed from the motor so that you can see what it looks like. Now, we have inside and underneath this photoelectric sensor a small plastic disc. This disc is graduated into 600 individual microscopic indexable positions. And what that allows us to do, and here's a picture of the disc that's underneath this encoder unit. And so it has 600 different indexable positions that have been encoded into this plastic disc. And what that does is it allows the motor to stop in a very, very precise position every time, time after time. Now, if we look at the higher or the lower end motors like this module, this only has inside here an 18 unit or 18 pole positioner system. That means that this motor can only stop in one of 18 positions as it's recognized by the control box. This motor can stop in up to 600 different positions, which allows for more instantaneous stops. And then also when the motor is running at a very slow rate of speed, this signaling disc is sending signals through this encoder unit to the main control box, which allows this motor to run at a very, very smooth, very, very controllable rate of speed when it's set down at a very, very low RPM. So the high-end motors are generally the only ones where you're going to see these encoder units because, again, it's a precision piece of electronics that allows the motor to perform very, very well. Also, we have printed our own manual for these motors. This is a manual that we designed and printed ourselves. A lot of other servo motors, when you purchase them, they just give you a little piece of paper that explains some of the basic functions and basic operations. But we have a very, very well illustrated, very comprehensive manual that shows all the different adjustability parameters on this motor. And this motor has 26 to 40 different adjustable parameters, so you can change certain settings on the motor. For instance, if you want to change the slow speed starting setup, if you want to change the maximum speed obtainable by the motor, if you want to change the minimum speed obtainable by the motor, if you want to change how quickly the needle goes up and down during the needle positioning cycle, and so forth. So all in all, it provides an incredible amount of adjustability, something that's not present on lower end motors in the market. So now we're ready to talk about the control box for this motor. This is the control box for the motor. It's a very, very nice control box. Has a lot of different options and adjustments on it. If you look on the back side of the control box, you can see all the different connectors. So these are all different accessories that can be purchased, one of which would be the needle positioner. It's an optional accessory if you'd like to purchase it with the motor. And then we also have a hookup for a light, which you can mount underneath the machine, a small DC light, and you have the ability to turn that light on or off into 4 different brightness settings here. We also have provisions for, if you wanted to add, we have provisions for a automatic presser foot lifter and an automatic reverse function as well. Those again would be optional attachments that you would add. Now you will have to purchase the actuator motors, and they would be model specific to your machine. You would wire them into the switch, a separate switch unit, which then you would connect with using these 2 connectors on the back of the motor. And then you would have the ability, by pressing a button on the modulated switch that attaches underneath the machine, you would have the ability to enter into automatic reverse, or you would have the ability to do automatic presser foot lift. So there's a lot of different options on the motor. Also, on the SL model, we have a separate light unit where you can connect a standard 110 volt gooseneck light to run, a standard 27-inch gooseneck or whatever light you'd prefer to run. It's set up to run on 110 volts. So a lot of options, a lot of ability to expand with attachments that you can add to this motor. So now we're going to take a walk over here, and I'm going to demonstrate the 750 SL motor in action. And the machine that we're demonstrating it on is our CB6900. This is one of our nicer walking foot cylinder arm lock stitch sewing machines. And I'm going to set the motor down to 100 RPM, which is the machine will run at a very, very slow rate of speed at 100 RPM. And so I want to demonstrate the punching capability. We're sewing through a couple layers of 3 to 4 ounce leather here. And I want to show how well this motor runs and how it's able to drive this medium weight machine at extremely low RPMs. So I'll go ahead and take off sewing here. And you can see at 100 RPM, this machine is moving at a very, very slow and controllable rate of speed. Now, mind you, we can cut this speed in half. We can actually make it go even slower than this if we want to. But right now, you know, just for the purposes of getting this video completed in a timely fashion, we decided to run it at around 100 RPM. So you can see how nice the stitching looks, how very controlled the stitching was. And we also have the needle positioner unit connected to this machine so that every time you stop the machine, and I'll demonstrate that, every time you stop the machine, the needle will automatically set itself down to the lowest position. You also have the option of setting it by pushing a button on the motor, by setting it so that it will go to its highest position as well. So this gives you an idea about the capabilities of the HM-750SL motor. And you can see it's a very, very nice motor, very well built. The highest horsepower, highest torque motor that's available on the market today, capable of sewing at extremely slow rates of speed and still generating bone-crushing horsepower and torque. If you have any additional questions about this motor or you'd like to purchase one, please give me a call directly. My name is Ryan Neal from the USA offices of Neal Saddlery and Harness, Cowboy Sewing Machines, and High-Tech Sewing Machines. You can reach me at area code 330-692-1418, and I do thank you for your time today.